Welcome to today's lecture on overview of the Flux architecture. This topic is an important part of Unit 5 in Advanced User Interface Technologies. If you have already learned React components and state management, today's session will help you understand how large React applications manage data efficiently. By the end of this lecture, you will understand why Facebook introduced Flux, the problems with the traditional MVC architecture, the four main components of Flux, how one-way data flow works, real-world examples, why Flux eventually led to Redux. Let's begin. Learning objectives. Today's learning objectives are: after completing this lecture, you should be able to first define what Flux architecture is. Second, understand why Facebook created Flux. Identify the four components of Flux. Explain one-way data flow. Compare Flux with MVC architecture. Finally, understand the advantages and limitations of Flux. These concepts are frequently asked in many examinations. Why Flux? Problems with traditional MVC. Before understanding Flux, let us first understand the problem. Most web applications originally used the Model View Controller or MVC architecture. MVC consists of model, stores data, view, displays data, controller, handles user requests. Initially, this works well, but imagine an e-commerce website. Many different pages use the same shopping cart. The cart appears in header, checkout page, product page, wish list. Now suppose a customer adds one item. Every page must update immediately. The model keeps communicating with multiple views. Views may also directly update models. This creates two-way communication. Problems include difficult debugging, circular updates, complex synchronization, unexpected bugs. When applications become large, developers spend more time tracking bugs than building features. Facebook faced exactly this issue while developing Facebook Chat and Newsfeed. Therefore, they designed a new architecture called Flux. What is Flux? So, what exactly is Flux? Flux is an application architecture introduced by Facebook for building client-side applications. Notice one important point: Flux is not a library, Flux is not a framework, it is an architectural pattern. Its main goal is predictable data flow. Flux has four characteristics. 1. Unidirectional or one-way data flow. 2. Centralized state management. 3. Stores whole application data. Number 4. Applications become easier to debug. Instead of allowing data to move everywhere, Flux defines one clear direction. Think of traffic. A one-way road has fewer accidents than roads where vehicles move in every direction. Similarly, Flux reduces software complexity. Components of Flux. Flux has four major components. Let's study each one. Component 1, Actions. Actions describe what happened. Examples include add product, delete product, login user, logout user, search product. Think of an action as a message. Let's take an example. User clicked add to cart. Component 2, Dispatcher. Dispatcher is the central hub. It receives actions, then it forwards those actions to all registered stores. Think of it like a traffic police officer. Every message passes through the dispatcher. Component 3, Store. The store contains application data. It also contains business logic. After receiving actions, the store updates its state. Examples include car store, user store, product store, notification store. Component 4, View. Views are React components. Views display data stored inside the store. Whenever the store changes, the view automatically updates. Users interact only with the view. The view never changes the data directly. Flux components explained. Let's summarize the responsibility of each component. Action describes what happened. Dispatcher distributes the actions. Store processes actions and stores data. View displays updated information. An easy way to remember is action creates, dispatcher distributes, store updates, view displays. This sequence never changes. One-way data flow. This is the most important one. Let us understand the complete data flow. The step 1, user performs an action. For example, clicking add to cart. Step 2, an action object is created. Example, add product. Step 3, dispatcher receives the action. The dispatcher sends it to stores. Step 4, stores updates the application state. Cart now contains one more item. Step 5, store informs React view. View re-renders automatically. Step 6, user sees the updated cart. Notice something is very important. Data always moves in only one direction. From user to action and then to dispatcher, dispatcher to store, store to view, view to user. No shortcuts, no direct updates. This predictable flow makes debugging much easier. Suppose if a bug occurs, developers simply check, was the action correct? Did dispatcher send it? Did the store update correctly? Did the view render correctly? Finding bugs becomes much easier. Let's take a real-time example. Let's understand Flux using online shopping cart. Imagine Amazon. If a customer clicks add to cart, action created. Add product, dispatcher receives the action, dispatcher sends it to cart store adds the product, store notices React updates the screen. Now the header displays cart 3 items. Notice that the customer never directly changes the cart. Everything follows one path. Another example is Facebook. When someone likes a post, The like action goes through the dispatcher, updates the store, then every component showing that post refreshes automatically. Advantages and limitations. Some advantages include predictable data flow, easy debugging, better maintenance, centralized state management. It's ideal for large applications. Developers always know where data originates. Limitations are more boilerplate code. It needs separate files for actions, dispatcher, stores, learning curves for beginners. Small applications may not need Flux. Today, Redux simplifies many of these problems. Let's quickly revise. Flux was introduced by Facebook. It solves problems of MVC. Flux follows one-way data flow. Its core components are actions, dispatcher, stores, views. The sequence is always user and then action and then dispatcher and then store and then view and then user. Flux improves maintainability, predictability, and debugging. Finally, Redux is actually inspired by Flux. In the next lecture, we will study Redux in detail and see how it simplifies Flux architecture. Thank you for watching this lecture. See you in the next lecture. Happy learning.